Hi, hello students, welcome to Let's Understand Physics. We are doing a revision series for class 10 students based on electricity chapter. Now in this video, I am going to explain you 3 questions based on resistors. Okay, so electric circuits connected with the resistors, how to solve to find equivalent resistance. Let's get started. In these 3 questions, I have one question based on these resistances, and then we have second question from IIT 1977 paper based on meter reading. Here they have given voltmeter reading. How do you find if resistance is given in the form of variable resistance? Understood? Next we'll see third question from IIT 1979, and here also resistance are connected in a different way. If you observe, you may feel it is in the difficult fashion, but when you start solving it will be very easy. Understood? Now these two questions were given in IIT question paper, but for now they are for school level students only. Understood? Now we'll try to solve them so that if there are any type of questions asked in these different fashions, you will be able to solve them. Understood? Now let's see first one. Determine the equivalent resistance of the network shown in figure. So this is the figure they have given. You have to find equivalent resistance between the terminals X and Y. Now X and Y are given. From X, if you start, you have to identify different resistors connected in series and parallel. If you are able to draw this diagram in a simplified manner, it will be easy for you to solve. Understood? Now let's identify. If for example here you have battery connected, then the current will start flowing, isn't it? Now how the current will be flowing? I'll just show with the arrow mark. Now this is the current, isn't it? Here positive terminal and negative terminal. Current, once it is reaching this point, it has to divide. Understood? Two paths are there for the current. Current will get divided. So that you need not to write I1 and I2. Just take the paths so that you will understand whether the resistances are connected in series or parallel. That's all. Understood? Now let's make it two paths. Here one path, here another path. Otherwise what I will do is, I will here take another color. Okay. Now for 10 ohm one path and 25 ohm another path. Now through this 10 ohm this current will pass. The same current will be passing through this 5 ohm also, isn't it? Now this two will get joined here, and then again they will get separated. Now this path, one is this side and the other is this side. Now this 5 ohm and this 5 ohm will have the same current. Understood? Now these two will have same current. These two will have same current. So the resistances which are having same current passing through them are connected in series, and the resistances where the current is getting divided and the current is getting joined, that particular resistance is in parallel with both of the resistors. Understood? Now let's simplify and draw one more diagram. If you observe here again, this 20 ohm resistance and this 5 ohm resistor current will come and join here, and it goes to negative terminal. I hope everybody understood this, how current is getting divided and how current is getting joined. Now let's simply draw diagram how we can understand and solve this problem. Understood? Now let's see. In place of x and y, I am just simply taking the supply. Now from here, if you see, 10 ohm and 5 ohm are in series, and for both of these resistances 25 ohm is in parallel. Understood? I am just going to take two resistors in series, and for those two, one resistance in parallel. Okay. You have to draw carefully positive terminal and negative terminal. The sizes you have to represent properly. And one more, 5 ohm resistance and 5 ohm resistance are in series. For those two resistances, you have, what is the value? 20 ohm resistance in parallel. So parallel I have drawn. In place of connecting here, simply here also you can connect from here. You can connect here. Okay. So that mark the values 10 ohm, 5 ohm, 25 ohm. So this is 10 ohm, 5 ohm, okay, and 25 ohm. These two are 5 ohm, 5 ohm, and this is 20 ohm. Understood? Now this one let's take this portion. If you observe, 10 ohm, 5 ohm are in series. Understood? You can name them as well. You can take R1, R2, R3, R4, R5 and R6. So R1 and R2 are in series. So when the resistances are in series resistance formula, Rs is equal to R1 plus R2 and so on. How many ever resistances you have in series, you have to add them. If it is the resistances are connected in parallel, then 1 by Rp equal to 1 by R1 plus 1 by R2 and so on. Understood? Now these are the two formulae you have to learn before doing the numericals on resistances. Now here we have Rs is equal to, for first part I am doing, Rs is equal to R1 plus R2. What are the values given? 10 and 5. So just add them. 10 plus 5. Rs I am taking for the first one, so Rs1 I will take. Rs1 is equal to 15 ohm. Then for this combination, you will have first one. I am just drawing only first one. Now it has become 15 ohm, isn't it? So 15 ohm. For this you have resistance. How much? How many ohms? 25 ohms. Now these two are in parallel. So 1 by Rp will be equal to 1 by 15 plus 1 by 25. Then what will be the LCM? 1 by Rp equal to 25. Then 25 into 15 you can directly take, or take the LCM 25, 15. What will be the LCM? 5 5s are 25, 5 3s are 15. So 5 5s are 25, 25 into 3 is 75. So 75 is the LCM. Okay. Now in 15, 75 will go How many times? 5 times. So 5 into 1 is 5, plus in 25, 75 will go 3 times. 3 into 1 is 3. Then 1 by Rp equal to 5 plus 3, 8 by 75. Rp equal to 75 by 8. Understood? Ohm. If you want, you can simplify more. Now, let's do for the second part of the resistance connection. That means this one. I'm taking blue color so that there will be differentiation. Okay. Now, 5 plus 5, 10 ohm, and this 10 ohm and 25 ohm are in parallel. Understood? Now, 5 ohm plus 5 ohm and 25 ohm is in parallel. 5 ohm will become 10 ohm and 25 ohm in parallel. So, this 5 plus 5 I will write 10 ohm. So, here R is 2 I am taking. It becomes R4 plus R5, isn't it? That is what we have taken names. So, Rs2 will be equal to 5 plus 5, 10 ohm. Then for this parallel, one more resistance is connected, which is 25 ohm. So, 1 by Rp2 we can write. 1 by Rp2 equal to 1 by 10 plus 1 by 25. Simplify. What is the LCM? 10 comma 25. 5 2s are 10, 5 5s are 25. So 5 2s are 10, 10 into 5 is 50. You will have 50 LCM 1 by Rp2. Now 10 will go in 55 times 5 and 50 will go in 25, 2 times, so 2 into 1 is 2. 5 plus 2 is 7 by 50. 1 by Rp2 equal to 7 by 50 we got. Then Rp2 equal to 50 by 7 ohm. Now these two will be in series, isn't it? Now we have found combination of this and combination of this. This one how much we got? 75 by 8, and one more we got 50 by 7. So just take it. Then total resistance, equivalent resistance is equal to Rp1 plus Rp2. If you take, equivalent resistance will be 75 by 8 plus, what is Rp2 value we got? 50 by 7. So you can simplify and write. For example, if we just take division, if we take, then divide it, how many times it will go? 8 ones and 8. 8 nines are 72. Point. Again 3 will be remaining, so 9.3 we can take. Now 7 sevens are 79, isn't it? 1 will be remaining. Let's take 2. Then equivalent resistance value we will get it as Re is equal to 9.3 plus 7.1. Add it. 9 plus 7, 16.3 plus 1 is 4 ohm. As video is becoming so lengthy, we'll continue this in the next video. Those who are interested, try to solve this problem. Thank you for watching. Please subscribe and share the video to your friends and relatives, those who are studying class 10 CBSE.